All right, geometry guys, this is going to be 3.5, isosceles and equilateral triangles. Now remember, by definition, equilateral means all three sides are congruent. Isosceles means two of the sides are congruent. So if I've got an isosceles triangle like I do here, what I need to say is AC is going to be congruent to BC. And because isosceles triangles have this kind of feature with it, angle 1 is going to be congruent to angle 2. All right? If these two sides are congruent, the opposite angles are congruent. All right? So angle 1 is congruent to angle 2. So if angle 1 is congruent to angle 2, then I can kind of say the reverse. Then I can say DE is congruent to FE. So DE is congruent to FE. So now, if I take a look here, if I need to find PN, well, first off, if this is 120 degrees, I'm told these are congruent to each other. I can recognize that that's an isosceles triangle because these two base angles are congruent. And since I know it's isosceles, I know that whatever this is, PN is, so PN is going to be 11 centimeters. That's what I know from there. So now take a look. This is another isosceles triangle. I know that because two of the angles are congruent. Anytime two of the angles are congruent, two of the sides have to be congruent. So that's by isosceles. So that means 2z minus 15 is going to be equal to 9. So once I add 15 to both sides, 2z is going to be 24. Z is going to be 12. So, we got a little proof here. So given LM is congruent to LP, prove angle M is congruent to angle P. Okay, so let's prove this here. So we start off with a proof. We start off with our given LM congruent to LP. That is given. All right, statement, reason. So let's take a look at what we have here. So since I know LM is part of both triangles, I'm sorry, LM and LP are congruent to each other because that is given. All right. So here's what I'm going to do. Okay, see how LN is dotted there? That means we're going to draw that. Okay, so that means we're going to connect LN. All right, and we are going to do so in a way such that it is perpendicular. All right, so we're going to draw LN is perpendicular. Why can I do that? Well, I can do that because there was a little theorem that we talked about a while back, and it was called the perpendicular line theorem. And here's all it said. Okay, it's very, very simple. If I've got a line and I've got a point not on that line, there is exactly one line that goes through that is perpendicular. There is exactly one line, one and only one. We also said the parallel line theorem. Through any line and one point not on the line, there is exactly one line that is parallel. So now I've said that this is perpendicular. But I've also drawn LN. So now I've created two triangles. So LN is going to be perpendicular to LN. Why are you perpendicular? Why are you congruent to yourself? Why? The reflexive property, of course. So the reflexive property allows me to say LN is congruent to LN. So now, if angle N is perpendicular, that would mean, or I'm sorry, if LNM is perpendicular, that would mean LNP is also perpendicular. So I would say angle LNM is congruent to angle LNP by definition of right angles. They're both right angles. So now, since I've proven these two congruent, hold on, let me back up here. I screwed up. I'm sorry. Let me back up. No, wait, I want to keep that statement. I don't want that. I don't want LN as perpendicular. I want LN is the angle bisector. Angle bisector. So what that means is that I cut this in half and this in half. All right, and the same kind of idea. All right, that's going to be by angle bisector theorem. So Ln is congruent to Ln. That's reflexive. That statement does me no good. So now I say that the triangles, there should be 3, the triangles are congruent by L, N, M, and that's congruent to L, N, P, and that is by side angle side. So now once I know that, then I can come back and use CPCTC. So I can say angle M is congruent to angle P by CPCTC. So each angle of an equilateral triangle. Well, I know a triangle's got to add up to 180 degrees. And since there's 3 of them, if I divide by 3, each angle must be 60 degrees. So a triangle is equilateral if and only if it is equiangular. That means if it's equiangular, it's automatically equilateral. If it's equilateral, it is automatically equiangular. So if it's 60, this is 5, this is 5, this is a combination. This is going to be a equilateral triangle, but at first glance it looks like an isosceles triangle. But if I realize that these two have got to be congruent because these two are congruent, this is 60, that leaves me with 120 divided by 2, that's 60, that's 60, it now becomes equilateral. So angle R is 60 degrees, angle P is 60 degrees, and PR is going to be 5. So if I look, let's see. So I know for a fact that this is at least isosceles. So I know because of that. But it also tells me that this is 4x minus 8 and this is 4x minus 8. So this must also be 4x minus 8. How do I know that? Because these two sides are congruent. That means these two angles are congruent. So if this is 4x minus 8, this is 4x minus 8. But this also happens to be 4x minus 8. So they're all three the same thing. There's only one possibility it can be because it's got to add up to 180. So it's got to be equilateral. So that means this equals this, which would have worked anyway because we already showed that it's going to be isosceles. So subtract 6y, subtract 6y, add 5, add 5. So y is going to equal 4. So x is going to take a little bit more work, but we're going to do it because it's worth the work. 4x minus 8 plus 4x minus 8 plus 4x minus 8 equals 180. So that's 12x minus 24 equals 180. So 12x equals 204. I'll move it over here. So if I divide 204 by 12, so let's see, that's going to be 184, 7. Yep. So x is going to be 17. Or another way I could have done that, and a way that might have been actually easier, since I proved that all three of these are congruent to each other, I could have just said, you know what, 4x minus 8 equals 60. And I could have done it that way too. That seems a lot easier. I should have done it that way. Why didn't you guys tell me that? Oh yeah, you're not really on this video. So take a look here. Same kind of situation. All right, these tell me it's isosceles. So if this is 2x, this has also got to be 2x degrees. But wait a second, this is 2x, this is 2x, this is 2x. There's only one situation where that works, and that's got to be equiangular, also known as equilateral. So to figure out my angles, 2x is going to equal 60, because each one of these has got to equal 60. That's the only way this works, if they're all going to be congruent to each other. Okay, so x is 30. By now, you should be able to divide by that very, very easily. All right, so this is 4y minus 5. If this is 3 inches, this is also 3 inches, but it's equilateral, so 4y minus 5 is going to equal 3 inches. So 4y equals 8, y equals 2. Let's take a look at this one. So that's 80 degrees. So we know it's not going to be equilateral, but we know it's isosceles because those two are there. So if this is 6x plus 8, this is also 6x plus 8. All right, so if this is 80, that means that this is going to be 100. There's 100 degrees left in the triangle, so that's got to be split evenly between the two. That means each one of these is going to equal 50 degrees. We also know 4y minus 2 equals 2y plus 2. So let's set these up. So I'm going to have 6x plus 8 equals 50. And 4y minus 2 equals 2y plus 2. So subtract 2y, add 2, add 2. 2y equals 4, y equals 2. So here, 6x plus 8 equals 50. So that's going to be 42, x equals 7. Whoop. Divide by 6, divide by 6. That is all I've got. All right, so make sure you guys keep these straight, and we will, and there's a test coming soon.